Hello, I'm teacher Ivan from Wuna Educational Services, a teacher of physics and mathematics at Angel High School, Namaswa. I welcome you to our second lesson. We are still looking at measurements, and in this very video, we shall be discussing about the physical quantities. What a physical quantity is? A physical quantity is anything that can be accurately measured. For instance, how old are you? I'm 40 years old. So anything that you can measure and tell the exact value is a physical quantity. We normally measure physical quantities by the help of instruments, as we shall see. So examples of physical quantities include age, length, height, mass, name them. There are very many. However, these many physical quantities are categorized into two. That is, fundamental or basic quantities and the derived quantities. Before we look at each category, I want us to first look at how do we present a physical quantity. Because we've said that it is anything that can be accurately measured, and therefore it is presented by two parts: the magnitude of the quantity and its unit. How old are you? I'm 40 years old. 40 is the magnitude or size of the quantity, and years is the unit of the quantity. How tall are you? I'm 5 feet. 5 is the size or magnitude, and feet is the units. So whenever you are writing a physical quantity, you must indicate the units. Hope we are together on that. Let us go to the categories. We have fundamental or basic quantities. These are quantities or physical quantities that cannot be expressed in terms of other physical quantities. For instance, mass. You cannot get mass using other physical quantities or using a specific formula. You only get mass by measuring using a beam balance. Time. You only get time after using a stop clock or a stopwatch. We have temperature. We have amount of a substance. We have luminous intensity. We have current, among other fundamental quantities. But at this level, we shall look at the major three. That is, mass measured in kilograms, time measured in seconds, and the length measured in meters. So our discussion will be on those three. Then when we look at the derived quantities, the word derived means they are obtained. Meaning, these derived quantities are physical quantities that can be expressed in terms of other physical quantities. For instance, area. We get area by multiplying length. So mean that area is derived or obtained from length. The same applies to volume. Length times width times height. Those three are just dimensions, but they are all under length. So volume is also obtained or derived from length. That's why we have meters cubed. Density. Density is mass over volume. So density is derived from mass and volume, among other derived quantities. So we shall look at the major quantities one by one. We shall start with length. Length is defined as the distance between two fixed points, and it is measured in meters as the SI unit, or the International Standard Unit of length. However, besides the meters, we also have other units, such as kilometers, hectometers, decameters, we have decimeters, centimeters, millimeters, we have feet, among others. And the length is measured using various instruments. Among the instruments that we use to measure length, we have the tape measure that measures longer distances. We have the meter rule, which measures distances between 0 centimeter and 100 centimeters. We have the half meter rule that measures distances between 0 and 50. We have the foot ruler. There are normally two kinds of foot rulers, the one that measures from 0 to 30 and from 0 to 15. We have the calipers, the vernier calipers and the inguinal calipers. Those measure very small distances. That is normally between 0 to 10 centimeters. Then we also have the micrometer screw gauges that measure very, very small distances, less than 1 centimeter. Among others, those are the major instruments that we use to measure length. Then we shall also look at the conversion of units of length. Remember, we have various units of length, and therefore that means that we can convert from one unit to another. So during the conversion of length, we use a special formula to help us memorize the conversion. That is, we shall use King held, your daughter Mary drank cold milk. And since we are talking about length, we shall put a meter on each, apart from the meter. So this is our SI unit, and these are other units. And therefore, we can convert from one unit to another. This is how we shall read. So from this, we can easily tell the equivalence of one unit in terms of the other. For instance, from this, we can tell that 1 kilometer is equivalent to 10 hectometer. And still 1 kilometer is equivalent to 100 decameters. 1 kilometer is equal to 1,000 meters. And 1 meter is equivalent to 10 decimeters. Still 1 meter is equivalent to 100 centimeters. So that means that we need to memorize this to help us convert from one unit of length to another. Otherwise, that is all about length. So in our next video, we shall continue to look at various physical quantities. We shall look at the mass, volume, area, among others. Otherwise, I'm teacher Ivan from Wuna Educational Services, a teacher of physics and mathematics at Angel High School, Namaswa. I welcome you to all our social media platforms, on all the social media apps. Search for Wuna Educational Services. Join us, follow us, subscribe to our channels, and we learn together. Bye-bye.